Okay. Hello everyone. I am Indroti Gain and presently I am a PhD scholar at Department of Mathematics and Statistics IIT Kanpur. And right now I am a PMRF fellow, and before that I had been CSR fellow. I have cleared my CSR NET with 108 rank. Okay. So in the previous lectures, we were discussing about trigonometric functions, and we have discussed about how we can measure an angle with respect to two different measurement concept like radian measure and degree measure, and how we can convert from one to another. After that, we shifted to the trigonometric functions, and with the help of sine and cosine function, we have discussed how we can define other trigonometric functions, and also we have defined the suitable domain and range of those functions, and how those functions looks like. We have discussed those things graphically. After that, we have in the last lecture we have discussed about the formula of a trigonometric functional value of some addition of two angle, and addition or subtraction of two angle, and we have seen the formula. Now, in today's lecture, we will do some suitable example, or you can say some example, and how can we use those formulas to get some results which are asked in the exams. Okay. So, in the last lecture, we have finished the lecture with these formulas, like these four formulas, you can say. Yeah. These formulas, you can say. And after that, we have came up with these formulas. Now, in today, we will try to apply this concept. Before that, let me start some simple example. So the first question is, prove that 3 sine pi by 6 sec pi by 3 minus 4 sine 5 pi by 6 cot pi by 4. This is equals to 1. We have to prove this. Now, here we can see that we almost know all the value of the functions, or all the trigonometric functional value at this given angles. So it is, if we just apply those values, we can get the functional value, and we can get the answer. So let's do that way. Sine pi by 6 pi by 3 minus sine 5 pi by 6 cos pi by 4. Now 3 will be remain here. What about sine pi by 6? Sine pi by 6 is 1 by 2. And what about 1 by cos pi by 3? So that will be equals to 1 by 2, which will again gives all together 2. Okay. Minus 4. Now what about this pi by 5 pi by 6? So it can be written as pi minus pi by 6. And what about cot pi by 3? It's cot pi by 3. It will be cot pi by 3. Okay. Cot pi by 3. So what about cot pi by 3? So cot pi by 3 is nothing but 1 by 10 pi by 4. And what is 10 pi by 4? That is equals to 1. So ultimately this will give us 1. So this is another thing. Okay. Now this will give us 3. And what will this give us? So here 4 will be there. Now what is the value of sine minus pi by 6? So in the last lecture we have done these things or not? Let's check. Okay. Here. Yeah. Sine pi by y equals to sine of y. Perfect. So we can write the sine y by sine pi by 6 multiplied with 1. Now what is sine pi by 6? Value of sine pi by 6 is 4 into half into 1, which will give us 3 minus 2, which will give us 1. So thus, just by putting or by knowing the value of some particular trigonometric function at some particular points, we have reduced the answer from this expression. So thus we have proved this statement. Okay. So let's go for the next question. Find the value of sine 15 degree. Now one can clearly see that 15 degree is not an well-known measure of an angle, and we usually don't know about what is the value of sine 15 degree. So we need to manipulate this 15 degree measure or 15 degree angle by some known angle with the help of known angle. So one can use this kind of thing like 15 degree means it can be equals to 45 degree minus 30 degree, or it can be of the form 60 degree minus 45 degree. Like you can do similar kind of thing. So the distance will be in between them will be 15, and you can manage how you want to. Okay. So in today case, I will consider this 45 degree minus 30 degree. So let us do this thing. So sine 15 degree, which is equals to sine 45 degree minus 30 degree. Now use the formula. Sine 45 degree cos 30 degree minus cos 45 degree. Okay. Degree sine 30 degree. Now, what is the value of sine 45? It will be 1 by root 2. And what about cos 30? Root 3 by 2. Perfect. And what about cos 45 degree? 1 by root 2. This is 1 by 2. Sin 30 is 1 by 2. So what we were obtained from here? Root 3 2 root 2 minus 1 2 root 2. So ultimately we obtain root 3 minus 1 divided by 2 root 2. Okay. So thus we can find the value of sine 15 degree. And similarly, if they ask for some more kind of this kind of angle, like one can ask what is the value of, okay, let's do another thing. Find the value of 1 35 degree. Okay. So how can one get 135 degree? So it can be of 180 minus 45 or 90 plus 45, right? So one can write 90 degree plus 45 degree or 180 degree minus 45 degree. Okay. Now just use this thing here. You can use the another and you can try to get the answer. But here just use this expression and we will proceed. So let us do cos 135 degree. This is equals to cos 90 degree plus 45 degree. Now use the formula for cos x plus y. What we will get? Cos 90 cos 45 minus sin 90 sin 45. So here it will be degree. Just maybe I have missed some places. So what about cos 90? Cos 90 is 0. So here it will be 0. So this will give minus 1 into sin 45 degree. And what will be sin 45 degree? That will be 1 by root 2. So this will give us like this. Thus you can find all the required values, and also you can use something like the value of sin 15 degree. Now using that, one can ask find the value of sin 120 degree. Okay. Now just check that 120 degree, this is equals to 135 degree minus 15 degree. Okay. So sin 120, this can be termed as 135 degree minus 15 degree. Yeah. Now, as we have proceeded for the case of cos 135, we can proceed in a similar way to get the value of sin 135, and we have already obtained the value for sin 15 degree. So using these two, we can and also we can find the value for cos 15 and sin 120 and all the things we can do, and we can put those values in this expression and we can find what will be the value of sin 120 degree. So by this way, one can find very different angles which are not that much well known to us, but just by manipulating or just by significant change of angles, or and you can find all the functional values of different angles. So you just need to figure out how you can obtain that angle using the known angle measures. Okay. So okay. So in the last lecture I have given two problem to formulate these two problem, question number 1 and question number 2. So let us discuss today right now. So we are already well known of sin x plus y and sin x minus y formula. So just use the formula. It is a given that sin x plus y divided by sin x minus y. So what will be the above section? Sin x cos y, cos x, sin y. And what will be the below section? Sin x, cos y, minus cos x, sin y. Okay. Now, what they are asking here? They are asking the expression in term of 10, and we obtain the form like this. Now, how can we get a expression with respect to 10? So for that, we need to get the function we need to divide the function by some cost. So now we have to decide which function we have to divide, but at least we have to, we are at this point, we are sure that we need to divide some cosine function, or from cos function, you can say. Cosine function and cos function is same. So we need to divide by cos function. So let's divide this color. Let's divide the numerator and denominator by cos x, cos y, and we obtain okay, sin x, okay, sin x cos y, cos x, sin y divided by cos x, cos y, sin x, cos y, sin y divided by cos x, cos y. This will give us sin x by cos x, sin y by cos y, sin x by cos x, sin y by cos y. This will further give us tan x plus tan y, tan x minus tan y. So just by manipulating, we can give we can prove sin x plus y by sin x minus y equals to tan x plus tan y by tan x minus tan y. Now, in the last class, we have already discussed one thing. Okay, where it was? Not here. Okay, where it was? Okay, okay, okay. Actually, the thing is like we have already we can reduce the formula for sin x plus y in terms of tan x and tan y. So from there also one can easily show this statement. So I have gone through using the straightforward formula for sin x plus y and sin x minus y, and then by dividing with the cos x cos y, and by doing the required steps. But one can use the formula for sin x plus y and sin x minus y in term of tan x appear to this result. So both way, whichever they are convenient, they can obtain that way and find this result. Okay. Okay. Now, what about the next question? The next question was tan 3x, tan 2x, tan x equals to tan 3x minus tan 2x minus tan x. So what we need to prove? Let's write once again. Need to So that tan 3x, tan 2x, tan x, this is equals to tan 3x minus tan 2x minus tan x. Now the thing is, from where you should start in this question. Let's start from this 3x. So only we can write 3x equals to 2x plus x. Okay. So what about tan 3x? Tan 3x will give us the formula tan 2x plus x. Now we can apply the formula for tan 2x plus x, that is tan a plus b formula or tan x plus y formula. So that will give us tan 2x tan x divided by 1 minus tan 2x tan x. Perfect. Now just use this inequality. These two are equal from the deduction. This clear. Then using that we can save tan 3x into 1 minus tan 2x tan x. This is equals to tan 2x plus tan x. Okay. Now just give these terms left and make other things right. What we will get? Tan 3x minus tan 2x minus tan x. This is equals to tan 3x tan 2x tan x. So here I have just skipped one extra step. That is, we have to just multiply in the left section that tan 3x in minus tan 3x, tan 2x, tan x, and then we have to keep all those terms. We just have to change the side of the term so that we can obtain the required answer. So that by doing the testing, we have obtained this expression. So it is nothing but just use of the formula or use of the formula tan x plus y. Just using that, we have obtained this result. Similarly, let us try another thing. Okay. We have till now we are using the formulas for 10x plus y, 10x minus and all those things. So let us do one first example for this formula using these formulas. We have discussed in the last last lecture, ending of the last lecture. So let us discuss one problem with this example in this formula. The question is, what? Cos pi by 4 plus x plus cos pi by 4 minus x. This is equals to root over 2 cos x. You have to prove this thing. So clearly, this here we can apply the formula of this. We can use this formula, right? So what is the formula? Cos x plus cos y equals to 2 into cos x plus y by 2 into cos x minus y by 2. So what is x and what is y here? Here x equals to pi by 4 plus x and y equals to pi by 4 minus x. And what is the given term? cos x plus cos y. What is the formula? 2 into cos x plus y by 2 cos x minus y by 2. Okay, so just put the value of x and y in the right hand side, what we and left hand side both sides. So what we will obtain? Cos y by 4 plus x plus cos y by 4 minus x, which is equal to 2 into plus x plus y by 4 minus x divided by 2 into cos pi by 4 plus x minus pi by 4 plus x divided by 2. So what we will get from the right hand side? 2 into cos pi by 4 into cos x. Now what is the value of cos pi by 4? That will give us 1 by root 2 and cos x will be remain same. So we will obtain root 2 cos x. Thus we have done the proof. Okay. Now let us do another example using this formula so that this can become more clear. To prove that, the question is prove that cos 7x plus cos 5x divided by sin 7x minus sin 5x equals to cot x. Okay, so we just need to use the formula here. Which formula? One is of the formula for cos x plus y, which is drawn in the white color again. I am marking here. And another one is this one. Okay, and what is the x and y here? X equals to 7x and y equals to 5x. So I am not denoting this 7x and 5x by capital X and capital Y. I hope you have enough understanding about this. So I'm just using the direct formula so that we can obtain the answer. So from left hand side, what we will obtain? Left hand side equals to what we will get? The formula will be 2 cos 7x divided plus 5x by 2 cos 7x minus 5x by 2. And what will be the denominator part? So that will be 2 sine, no, 2 cos 7x plus 5x by 2 by 7x minus 5x divided by 2. So 2 will gone. This will also gone. What we will get? Cos x by sin x, which is nothing but x. Okay. So just using the formula, we have obtained this thing. Similar way, we can do many different examples. So let's do another example of this formula. I'm not writing what we want to show, just doing the steps. Let's see what we will obtain. So the given expression is sin 5x minus 2 sin 3x sin x divided by cos 5x minus cos x. Now we need to simplify this given expression for trigonometric functions, and to obtain what is the simplest form we obtain from here. We can obtain from here. Okay. So let's do. Okay. So this can be written as, here we have 2 involved in this case. So I will not. I will remove this thing first, and we will do the other term. We will do some calculation with the other terms. So what will we get? Sin 5x plus sin x minus 2 sin 3x divided by cos 5x minus cos 3x, which can be written as 2 sin 5x plus x by 2 sin minus x by 2. Okay. Now, if we use the above formula, what we will get? We will get 2 sin by 2 cos 5x minus x by 2 is given minus sin 3x divided by minus 2 sin 3x cos, it will be sin 2x. Okay. Now, what we obtain from above? 2 sin 3x cos 2x minus 2 sin 3x divided by minus 2 sin 3x sin 2x. Now you can check that from numerator and denominator we can remove sin 3x. So we obtain, and also we can remove 2. So we can obtain an expression of the form 1 minus cos 2x divided by sin 2x. Okay. Now we know the formula for cos 2x, right? And now, which formula should we use? That's the question. Now we can use 2 formula here, so we can do 2 different cases. That will be better for the first time understanding. So for sin 2x, we have only one case. That will be 2 sin x cos x. But what about 1 minus cos 2x? So let us apply the formula 2 cos square x minus 1. So what we will obtain from here? 1 minus 2 cos square x plus 1 divided by 2 sin x cos x. So we will obtain 2 1 minus cos square x divided by 2 sin x cos x. So we will get 2 sin square x divided by 2 sin x cos x. So we ultimately obtain sin x by cos x, which will give us tan x. Now if we apply the formula for sin for cos 2x, that is, if we apply the formula like 1 minus 2 sine square x, which is divided by 2 sine x cos x, how do we obtain? We obtain 2 sine square x divided by 2 sine x cos x, which will give us, clearly you can see, which will give us 10x. Okay. Now you can clearly see, just using any formula of cos 2x, we can obtain the answer. That is, the expression will be equal to 10. But the point is here is that in the first case, whenever we consider cos 2x equals to 2 cos square x minus 1, in that case, the procedure is little longer, right? We have to do a lot of steps. We have to go through cos square x formula, and after that we have to convert that cos square x in terms of sin square x, and after that we obtain the answer. But if we obtain the second way, if we obey the second way, then we can see that it is very much simple. Just by fewer steps, just by 2 or 3 steps, we can obtain the answer. That's why you should be very much careful in the choice of formula to get the answer. You should feel that thing, that which formula will be easier to get the answer, or which formula will be easier to obtain the answer. In this case, we haven't any idea about the answer, so we were unaware of that which way we should obtain to get the answer. But usually they ask to prove these things in the board level exam, and for joint exam they ask you to put some values. So we will see some more example about those. Then you can understand how we can choose some functional formula depending upon your choice of answer. Okay. Okay. So let us do an example. Okay. Okay. So let us find the value of x. Find the values of x such that sin x minus 3 sin 2x plus sin 3x, this will be equal to cos x minus 3 cos 2x plus cos 3x. Okay. So what is the question? What is the demand of the question? The question is in the demand of the values of those x, such x values, which should follow this equality. For which value of x this equality will hold. So for that purpose, we need to solve this equation. How you can solve? So in the first step, what can we do? You can put all the values in one side. It will be little easy. Sin x minus 3 sin 2x plus sin 3x, this thing is there, minus cos x minus 3 cos 2x plus cos 3x, this is equal to 0. Okay. Now, as we have discussed in this question, that we have taken this one and this one, not this one. Similar way, we will take this one and apply the formula for sin x plus sin y. So what we will obtain from there? We can obtain from there that we will get the formula 2 sin 3x plus x by 2 cos 3x minus x by 2 minus 2 sin 2x. This is one term minus what will be the formula for cos x and plus cos 3x. So the formula for cos x plus cos 3x will be 2 cos x plus 3x by 2 cos 3x minus x by 2 minus 3 cos 2x. This is equal to 0. So we obtain here like 2 sin 2x cos x minus 3 sin 2x minus 2 cos 2x cos x minus 3 cos 2x is equals to 0. Now you can see that we can take common from sin 2x and cos 2x from both the bracket inside bracket terms. So let us take common sin 2x. So what we will get? 2 cos x minus 3, and what we will get from here? Cos 2x 2 cos x minus 3 by 0. Now see, these two terms are common, so we can take this common. 2 cos x minus 3 sin 2x minus cos 2x equals to 0. Okay. This thing implies that product of two numbers are 0. So at least one should be 0. Now case 1, if we say 2 cos x minus 3 equal to 0, this will imply cos x equals to 3 by 2. Now one can ask that okay, this is the answer, x equals to cos x equals to 3 by 2. So we just need to find the value of those x's which can give us the value 3 by 2. Now one can clearly see one fact that 3 by 2 is greater than 1. And in the beginning of this lecture, we have discussed one factor that cos x, the value of cos x and sin x cannot be exceed the value 1. That is, we knew the fact that minus 1 less than equals to cos x less than equals to 1, minus 1 less than equals to sin x less than equals to 1. Now, by this equality, we have to, if we want to get the 0, if this term is non-zero, then this term will be 0 and this term will give us this and this, which is not fine. This is not fine. We can't say this. So this term obviously will be not equal to 0. This can be 0. You can write since this term is not equal to 0. Therefore, we have sin 2x equals to cos 2x. Okay. Now one point is that when the value of sine and cos function will be same. Okay. So for that, one can draw the graph of the sine and cos. So this is the curve for sine function. This is the curve for cosine function. Yeah, like this. Okay, and you can see these two functions intersect at the point pi by 4, at the point 3 pi by 4, right? At the point 5 pi by 4, like this. Like they are intersecting at some point. Maybe I haven't drawn the graph properly, but yes, they will cut at the point some multiplication of 5 pi by 4. Okay, one concept is this. Another guy can think like this. This will give us like tan 2x equals to 1. This means 2x equals to, when tan x equals to 1, when it will be pi by 4 or integer multiple of some pi by 4, right? Pi by 4. And we know that the value of 10 repeats after each pi step. So we can write this like n pi plus pi by 4. Why? Because after each pi step, we have discussed in the last lecture that after each pi step, the value of 10 will repeat. Now we need to collect all those values of x, or you can say all the values of 2x, which will give the value 1. Now for which value of 2x, the value will be 1, that will be n pi plus pi by 4. Because for n pi, the value will get repeated, and for pi by 4, you will get the value 1. Okay. So from here, what will be the value of x? X will be n by 2 pi plus a. So one can observe from the graph of sin x and cos x, but that will be little difficult. So it will be better to understand from the help of tan function, and from there one can clearly see that after n pi, after pi integer multiple of pi value, the tan value gets repeated. From here, one can tell the perfect values of x for which this equality holds. So what we have done in this question, we just considered this equality. Now we have solved the equations and used the formulas for sin x plus y and sin x minus y. And using those formulas, we obtain the expression when the equality will come. Now, why this is not equal to 0? Because if this is 0, then sin x becomes, cos x becomes 3 by 2, which is not a possible case. So the other term will be obviously 0. So from there, we have found the value of x for which this equality holds. And from there, we can find the value of x's, all possible x's. Let us do another example. Okay. The question is, if tan of cot x, this is equals to cot of tan x, then sin 2x equals to what? What will be the value of sin 2x? Okay. So let us use the, from here, we know what will be 10, given that tan of cot x equals to cot of tan x. Now, what will be the cot of tan x? Cot of tan x can be written as, okay, let us do one small example here right now. Tan pi by 2 minus tan x. What we will get from here? So let us do these things. Tan pi by 2 minus tan x means tan pi by 2. Okay, how can I do it? Okay, 10 pi by 2 minus 10 of 10x. Okay, I'm doing something wrong maybe. Okay, yeah. And what will be the answer? 1 minus 10 pi by 2, 10 pi by 2, 10x. Okay, now we have used the formula. Now we are aware of that we can't define 10 pi by 2, right? Because at the point 10 pi by 2, what will we get? Sin pi by 2 by cos pi by 2. So we can't define the value of cos pi by 2, 10 pi by 2, because cos pi by 2 is 0. That's why we can't define 10 pi by 2. So that's why we will replace this 10 pi by 2 by cot pi by 2. 1 by cot pi by 2. This will give us 1 by cot of 10x divided by 1 minus 1 by 1 by cot pi by 2 cot of 10x. Correct? Now, doing the things, we can easily show that we will obtain here cot of 10x minus cot pi by 2 minus uh, divided by cot pi by 2 cot of 10x minus 1. Okay. Now, what about the value of cot pi by 2? This will give us cos pi by 2 by sin pi by 2, that will be 0. So, cot pi by 2 is 0. It will give us what? Cot of 10x. This will give us cot of 10x. Okay. Now, here we have already cot of 10x. So, we can write it as, we can write this expression by what? Tan of cot x equals to cot of 10x, which can be replaced as tan of pi by 2 minus 10x. Okay. Now, these two values are same. So, this will give us the angle will be of in 2 pi distance. So, from here, one can write this thing implies cot x equals to n pi plus pi by 2 minus 10x. So, this will give us cot x plus 10x equals to n pi plus pi by 2. Fine. Now, how we can write this thing? So, the lower term will be sin x cos x, and the upper term will be cos square x plus sin square x, which will give us 1. And this will give n pi plus pi by 2. Now, this will give us 1 divided by sin x cos x. This equals to n pi plus pi by 2. If we divide both sides by 2, what we will get? This thing. So, we obtain 1 by sin 2x. This is equals to n pi by 2 plus pi by 4. So, what we will get from the formula sin 2x? So, sin 2x equals to 1 by n pi by 2 plus pi by 4. Yeah. So, thus we can obtain the value of sin 2x. Now, by looks wise, it is not that much convenient. It can be an answer, but yes, it is the answer. how you can simplify this answer a little bit. So how can I simplify? Just you can write like n pi by 2n plus 1 into pi. You can just simplify this by doing some calculation. So this is the answer. Okay. So thus, of using those formulas, one can easily calculate different expressions and different value at different angles which are not known to us, using the values which are known to us. Okay. So here we can end this lecture series that about trigonometry function. So next day we will start some another topic. Okay. Thank you.